45 meters, and what is the final velocity? We'll start out from a standard equation. dF equals di plus vit plus 1/2 at squared. I'm going to take this equation and turn it into my free fall equation. So I'm going to combine dF minus di on one side Now, if you drop something, it did not have an initial velocity. So if initial velocity is 0, that means this whole term will fall out. We're left with our change in distance equals 1/2 at squared. When we're dealing with height or free fall problems, we call the change in distance height. And we call acceleration here on Earth gravity, or g, t squared. So this is our free fall equation. Now, in this case, we have to solve for time. So I'm going to move everything to where I can solve for this variable. Multiply both sides through by 2. I get 2h equals gt squared. I'm going to divide everything through by g, and I get t squared is 2h over g. Now, I'm not solving for t squared, I'm solving for t. So t is the square root of 2h over g. Now we're just going to plug in our numbers. Remember, when we use dimensional analysis, it's going to look just like this. Plugging in the numbers. Two times 45 meters over 1 divided by 9.8 meters per second squared. Look at our units first to make sure we're ending up with the right thing. When we divide these numbers, we're going to cancel meters. We're left with seconds squared under the square root sign. When we take the square root of seconds squared, we end up with seconds. So since we're solving for time in seconds, we've set our equation up correctly. Now, just dealing with my numbers, 2 times 45 is 90 divided by 9.8, and I'm just going to go ahead and round it to 10. So we get the square root of 90 divided by 10, or the square root of 9, which is 3 seconds. So it takes 3 seconds to fall or to reach the ground. Now the second part is finding out the final velocity. If we just go to our regular velocity is our change in distance divided by time. And this is going to give us an average velocity. Our change in distance was 45 meters. The total time was 3 seconds. So it took 3 seconds, but the average velocity was 15 meters per second.